Hello, this is Mrs. Poland for Algebra 2. In this video, I'm going to go over additional problems from the Unit 2 review sheet. For the first problem, they ask you to solve the following equation for all real solutions in simplest form using the quadratic formula. The quadratic formula appears on the reference sheet, but it is a good idea to memorize it. You'll notice that in example 10 that the quadratic equation is not in standard form. We have to add x to both sides of the equation before we can pull off the coefficients. So a is the coefficient attached to the x squared term, only the number. B is the coefficient attached to the x term, the negative 16, and C is the coefficient the constant. We now carefully substitute it into the formula. So it's negative 16 squared minus 4 times A times C, and that whole quantity is over 2 times A. So the negative 16 becomes positive 16. What's under the radical, that radicand, is the discriminant. And we're going to simplify that using GeoGebra. You'll see that I've already entered it into GeoGebra. Notice for that b squared term, I made sure to enclose that negative into parentheses. Otherwise, you're liable to get the wrong answer, okay? So it's really important. So this simplifies to 76. And that whole quantity is over 2 times 3, or 6. Now, before you continue, so you don't make a careless error, you have to simplify that radical first. You can't reduce the 16 and 6 until that square root of 76 is simplified. Otherwise, you will get the wrong answer. So this breaks into the highest perfect square and non-perfect square. So the highest perfect square is 4, and the other factor is 19. So this simplifies to 2 square root of 19. Now you can start simplifying. But when you simplify, you have to look at all 3 terms, the coefficients of all 3 terms. I call them the triplets. What's in common to the 16, 2, and 6? That would be 2. So 16 divided by 2 is 8. 2 rad 19 divided by 2 is rad 19. And 6 divided by 2 is 3. You cannot simplify this any further. So your final answer is 8 minus square root of 19 over 3, comma 8 plus square root of 19 over 3. You do not have to simplify. You can write this as 8 plus or minus square root of 19 over 3. I just wanted to emphasize that you have 2 solutions, and they're actually conjugate pairs. The only difference between the 2 is the plus or minus in between the 2 terms. I now like to do problem number 2. Here we have another quadratic equation, but we're asked to solve in simplest form using the completing this square technique. This is a totally different technique from the quadratic formula. In order to use this technique, your leading term, that x squared term, has to have a coefficient of 1. Since this one does not, you have to divide all terms on both sides of the equation by 6. You get a modified equation, x squared plus 16x minus 44. The next step in this process is to get the constant on the other side, and we do so by adding 44 to both sides of the equation. We now complete the square by adding on a term to both sides of the equation. The add-on term is b divided by 2 squared. So in this case, it's 16 divided by 2 squared. That's 8 squared, or 64. So I add 64 to both sides. Make sure it's both sides of the equation. On the left-hand side, we factor. So this becomes x plus 8 times x plus 8 is equal to 108. We can then represent the left-hand side as x plus 8 squared is equal to 108. We then take the square root of both sides, and we get x plus 8 is equal to plus or minus square root of 108. Again, before you go on to the next step, important to follow directions. You have to simplify the radical into the perfect square and non-perfect square. I first take 108 divided by 2 and I get 54. Neither 54 nor 2 are perfect squares, so I take 108 divided by 3 and I get 36 and 3. So this simplifies to 6 rad 3. So this becomes x plus 8 is equal to plus or minus 6 rad 3. And for the final step, we subtract 8 from both sides. And we get negative 8 plus or minus 6 rad 3. So this is negative 8 minus 6 rad 3 and negative 8 plus 6 rad 3. Could you write it as negative 8 plus or minus 6 rad 3 in your final answer? Yes. I wanted to emphasize that you have two solutions, and the only difference is the plus or minus. This, again, is called a conjugate pair.